Hi dear doctors, welcome to the class of 𝗲𝗵𝗵𝗆. Myself Dr. 𝗲𝗵𝗵𝗺. We are discussing about the cardiovascular system or pediatric cardiology, and the topic of discussion is Truncus arteriosus. Now what is Truncus arteriosus? See, in this Truncus arteriosus is actually a pediatric structure. It's an embryological structure which is responsible for dividing the pulmonary trunk and the aorta. Okay. So normally if I just show you, this is actually the Truncus arteriosus, okay, and this Truncus arteriosus, you can clearly see, there's aorta and there is pulmonary trunk like that because of the presence of this aorticopulmonary septum, and this aorticopulmonary septum is something which develops from the Truncus arteriosus, and this aorticopulmonary septum is something that is going to the division between the aorta and the pulmonary trunk. So if there is no Truncus arteriosus, there is no aorticopulmonary septum which is going to be there, and of course there will be a cute little amalgamation, okay. There will be failure of Truncus arteriosus to divide the pulmonary and artery and aorta, and what is going to happen then? There will be single arterial trunk. So of course the mixing of blood is going to happen, and that is why it is going to be a cyanotic heart abnormality, which is actually called as Truncus arteriosus disease. Truncus arteriosus. So basically Truncus arteriosus was supposed to develop into a septum. So if it is not developing into septum, it is going to persist as a Truncus arteriosus, which is a common channel. So you can see now very well, Truncus arteriosus is a common channel between the two arteries, pulmonary artery and the aorta. So this Truncus arteriosus is something which is very much associated with your DiGeorge syndrome. Okay. So please remember that DiGeorge syndrome, di means two and two means two words. Two words means one is T and other is A, Truncus arteriosus. Okay. So what is going to happen? Of course, there is going to be a poor oxygenation due to mixing of systemic and pulmonary blood. There is going to be pulmonary hypertension. Why? See, because there is less oxygen, and it's a dictum. This you have to understand, that if there is a less oxygen which is going to be there, it is responsible for causing vasoconstriction, and this vasoconstriction is especially going to occur in the pulmonary artery. So the pulmonary artery is going to show you vasoconstriction. Okay, and of course, because of the persistent pulmonary hypertension and decreased oxygen, now the oxygen is less, but the heart muscle is supposed to work more because it has to pump the blood into a very wider channel. That's a common arterial channel, and that's why it causes congestive heart failure to happen. So of course, see what is going to happen, both the ventricles, please understand, both the ventricles are going to pump into the same low resistance pulmonary circuit. Blood preferentially flows into the lungs, leading to volume overload of the left ventricle. Okay, so there's a lot of blood which is going to come into the left ventricle, which actually receives the increased pulmonary venous return, which is going to receive the increased pulmonary venous return. So that's why you can very well see that there's a volume overload which is going to happen in the left ventricle. Then next there will be tachypnea, there will be poor feeding, failure to thrive. All these things are going to occur. And how to decrease this volume overload? We have to supply diuretics. We have to give oxygen also because oxygen is less, and of course ACE inhibitors. So diuretics and ACE inhibitors, both of them are responsible to decrease the volume overload. Okay, to decrease what? To decrease the volume overload. And what is the definitive treatment? So the definitive treatment is to do a surgical correction during the neonatal period. That's a treatment of choice. And there are actually two types of classification. One is called as Collett-Edwards, another is called as Van Perag. So Collett-Edwards and Van Perag, these are two types of classification. But what I have to tell you is, just 1, 2, 3, 4 and A1, A2, A3, A4. So Van Perag Van Perag has this 1, 2, and this Collett one has got 1, 2 in Roman numbers. So this is just a minor difference. So what happens actually is, so there is a common main pulmonary artery that is going to get formed from the truncus, divides into the right pulmonary artery and the left pulmonary artery in type 1. In type 2, they are separate, but close. So again, the right pulmonary artery and left pulmonary artery origins are actually separate but very close. And in A3 there is only one pulmonary artery that is going to get developed, okay, from the truncus, and in A4 there is no pulmonary artery which is going to develop from the truncus, and lungs are going to take the blood via the collateral supply. Now it is called as PAVST. Anyways, this is actually a PG topic, not for you guys, but then still I mentioned it because sometimes if you're giving an extremely good viva, this classification, Van Praag and Colleton Edwards classification, is something which your examiner can ask. Okay, so with this I will take a goodbye from you all, and thank you so much for watching this video.